Hi grade 12s and welcome to our second session of electric circuits. We are continuing with past papers. I will be taking you through the 2018 past paper, and what this question is asking is for us to calculate the value of resistor R when the total resistance of the circuit is 4.8 ohms. Right, what is important to note about this circuit of ours is that it has combined both parallel and series connections. Right, when you start from your positive side to your negative side, you realize when you get here, there is current being shed because we are observing a parallel connection. But in this section of the parallel connection, we also have a series circuit. These three resistors are connected in series with each other. But what we also know is that RS, to resolve the series circuit, we just add the resistors together. Right, RS is equals to R1 plus R2 plus R3. Right, total resistance in series would be 3R plus 2R plus R, which gives you 6R. Right. And so the question is not asking for you to resolve the series connection. But since we have resolved the series connection, what we can take from this is that we can resolve our circuit as well. We can have something of this nature. After we have resolved the series connection, this will be our 4R, and this would be our 6R. Right. And so what you observe from this is that you now only have two resistors connected in parallel, right? And so now for you to calculate the total resistance, you are going to use a parallel equation, right? We have two equations. You can use this one, 1 over Rp is equals to 1 over R1 plus 1 over R2, or you can also say Rp is equals to R1, R2 over R1 plus R2, right? But for this second equation, you know that we only use it when we have two resistors connected in parallel. And in this case, we do have two resistors connected in parallel, right? And what you do from now on, you are going to replace the Rp with 4.8, you have 4.8 ohms is equals to R1, we'll say it's 4R times 6R over 4R plus 6R. And from here on, what is just going to work is you basically doing mathematics. You will cross multiply. This is almost like it's over 1. 4.8 times 4R plus 6R, that's 10R, is equals to 24R squared. And then you can divide both sides by 10R, 24 divided by 10. That will give you a decimal. Very preferable to use something that will give you a whole number. So let's start by dividing with 4.8R on both sides. And then on this side, you're going to be left, let's take it here, with 10 is equals to 24 divided by 4.8. You get 5R. And for you to get R, you divide both sides by 5. And 10 divided by 5, you get 2. So that means the value of your R is 2 ohms. Right? So we are done with 12.1. We are moving on to 12.2. Let me just erase this. We are still going to make use of this circuit, I will just draw it up there for easy reference. Let me quickly do that. Right. Okay, let me use this big one. Now the second question is telling you that is asking you to calculate the reading on the voltmeter if the current through the 4R resistor is 1.8, right? But what you know about, when you go on your side, on the side, what you know about resistors in parallel is that they have the same voltage. And so you can first start by calculating the voltage that passes through 4R, because you are given that the current that passes through 4R is 1.8. And so you use Ohm's law to find the voltage, right? You know that your equation is V is equals to IR. You are looking for the voltage, and you are told that your current is 1.8 amps. And then your resistance, it's 4R. Remember, we just calculated the value of R, which was 2. But the equation is 4R. So it's going to be 1.8 times 4 times 2. Right? And then when you put it in the calculator, you have 1.8 times 4 times 2. And you get 14.4 volts. Right, this will be your first step. Right, and then you know that the voltage that passes through this part is 14.4 volts. Right, but what you know also about resistors in series is that 14.4 volts will be shared amongst these 3 resistors. Right, and so they want the voltmeter through the reading of the voltmeter, and the voltmeter is only in the 2R resistor, right? And they know that voltage is shared among the 3 resistors. If this was just one connection, you would have voltmeter of 14.4, but it is shared among these 3, right? What you also know is that the current that flows through here is 1.8 amps. And what you know about resistors in series is that they have the same current. That means the current that goes here is the same current that goes here, and is the same current that goes there. Right. And then we are going now to calculate the current of this whole thing, because it's going to be the same current. Right, and we can use this 6R, right, because it is connected in parallel. Right, I'm going to say V is equals to IR. You can make I the subject of the formula, and then you're left with I is equals to V over R. You want the current that's flowing through here or through here. You have a voltage of 14.4 over resistance is 6R. Therefore, your current is 1.2 amps. Right? So now you know the current that flows through all these resistors. Right? And the 14.4 is the voltage that is at 6R. That is here. But you need to know the voltage at each point of these resistors. Right, so and the voltmeter is connected on the 2R resistor. That means you want the voltmeter reading at 2R, not at 6R. Right, and from here on, you are going to calculate the voltage at the 2R resistor. You know the current will be the same. That's 1.2 amps times 2R. But what do you know? The value of R is 2. So it's going to 1.2 times 2 times 2. And your voltmeter reading would be 4.8 volt. That's how you get to your answer in 1.2. Right, moving on. To 1.3. Okay, let me fix that quickly. One 12.3 says calculate the energy converted in resistor 4R in 2 minutes. Right? The first thing to notice is that it is given in minutes and we deal with seconds. Time is measured in seconds. Going back to our conversion, hours, minutes, and seconds, right? 60, not 60, 60. For you to move from seconds to minutes, what do? You divide by 60, you divide by 60, and then when you go that side, you multiply by 60. And we are moving from minutes to seconds, right? You have 2 minutes, so you're going to say 2 minutes times 60. That means your time would be 120 seconds, right? And then you do know that for 4R, for the resistor 4R, you already have the current. Your current was given, was 1.8 amps, right? And then you can calculate the value of resistor R. 4R is equals to 4 times 2, which is 8. And when you go to your formula sheet, you can check which formula will work best for you when you're given all these parameters, right? And you can use this one, right? Is equals to I squared R times change in time. And then you put your 1.8 amps, remember it's squared, times your 8 times 120 seconds. And then your answer is in joules, right? You put that in the calculator. Squared times 8 times 120, and then you get 3,110.4 joules, and that will be your answer for 12.3. Excuse me. Moving on to 12.3. 12.4. Excuse me. 12.4 says the 4R resistor is replaced with an ammeter. How will the reading on the voltmeter be influenced? Right, only increase, decrease, or stay the same. Right, let's just also incorporate 12.5. What do you know about the ammeter? What properties does an ammeter have? Right, number one, we learned that an ammeter has very low resistance. And so low resistance means more current that flows through it, right? So when you go back to your diagram, it says that when now there's a very low resistance here, that means all the current will pass here and very few current will pass this side because of the low resistance that's here, right? And they're asking, how will the reading on the voltmeter be influenced? So if there's low current passing through here, remember according to Ohm's law, current is directly proportional to the voltage. So if there is low current passing through this side, that means voltage will also be affected and it would be low as well. So that means your reading on the voltmeter would be decrease. Right, in 12.5, they're asking you to explain your answer. This is where you tell us about your low resistance on your ammeter. And then you also tell us that because of the low resistance, a lot of current will pass through there, and therefore low current on the voltmeter, consequently low voltage. Right, that's how we answer our first question.